Today we're going to talk about the last of our conic shapes, and that is the hyperbola. Now, the hyperbola has some similarities and differences to the other conics, and the hyperbola has, you may think of it as two parabolas, here and here and here and here. And each of those parabolas has its own vertex and its own focus. And we're going to have those A, B, and C values that we had for ellipses. And our A value tells you how far from the center your vertices are. So this is A units, and this distance is also A units. And then we have other co-vertices. These are co-vertex and a co-vertex. Those are B units away from the center. Now with ellipses, the distance that the vertices were farther apart from the center than the co-vertices were, but for ellipses, that's not always going to be the case. You could have your co-vertices further apart than your vertices. So this is the general shape, and we could have horizontal hyperbolas, which is what this picture is, or we could have vertical ones. And then the vertical ones, your parabolas would be opening up and down. Here they're opening left and right. So the standard equation for a hyperbola, one last thing. The segment that connects the two vertices, that is called the transverse axis. The transverse axis. If the transverse axis is horizontal, then that is a horizontal hyperbola. If the transverse axis is vertical, then it's a vertical hyperbola. And we're going to talk about how to tell the difference between the two. So if the transverse axis is horizontal, that means our x term is positive. It's going to be x minus h squared over a squared. And it looks like an ellipse right now, but instead of a plus sign, it's going to be a negative sign. So if your x value is positive or in front, that is a horizontal ellipse, horizontal hyperbola with a horizontal transverse axis. If it was a vertical hyperbola, then the y part is positive. So y minus k squared over a minus x minus h squared over b squared equals 1. Next, that's a vertical hyperbola, which would look like this, and a horizontal one would look like that. So when we draw these, we have more information to dissect. So each parabola has two asymptotes that intersect at the center of the hyperbola, and the asymptotes pass through the vertices of a rectangle with dimensions 2a by 2b with its center at h comma k. I know that sounds very intimidating right now, but when we start to draw these, you will find that it isn't bad. The transverse axis is always 2a units. Okay, we talked about that, where it's a units from, your vertices are a units away from the center. The conjugate axis, that is the one that connects the co-vertices, and that is 2b units away. And then A, B, and C, the same thing they did with an ellipse. A is the distance from the center to the vertex, B is the distance from the center to the co-vertex, and C is the distance from the center to the focus. Now, for ellipses, it was c squared equals a squared minus b squared. That was for ellipses. But for hyperbolas, c squared is equal to a squared plus b squared. We also have eccentricity, which is calculated the same way as the ellipse. So it's very important that you are practicing these and you're able to differentiate between the different conics and what rules they have. So on the next page, we're going to graph these. And I have the steps up here, but instead of reading them and then doing it, I think going back and forth between these steps and doing them will make things a lot easier. So that way you can see how everything is connected. So we're going to find the center, vertices, covertices, foci, and asymptotes of the hyperbola and sketch its graph on the graph paper. So first we're going to determine, is it horizontal and vertical? And we see up here, that is what I have, step one. If the x fraction is positive, it's horizontal. If the y fraction is positive, it is vertical. So the x1 is positive, it's first. Here's the negative sign for the y. So this is a horizontal hyperbola, so we know it's going to go that way. A squared is equal to 16, which means a is equal to 4. B squared is equal to 25, so b is equal to 5. With the ellipses, the larger value is always a, but that's not the case for hyperbolas. This case, our b is larger than a. And then c squared is a squared plus b squared, so that is equal to 25 plus 16, which is 41, which means c is equal to the square root of 41, which is about 6.4. So the center of our ellipse, our h comma k, that is positive 3 comma negative 2. So I'm going to go down and plot that. Positive 1, 2, 3, and negative 2, 1, 2. Now, our transverse axis is 2a units long, or we can say we're going to go from the center a units left and right. So 4 units. 1, 2, 3, 4. There's one vertex. 1, 2, 3, 4. There's another vertex. Now the covertices go, we're going to go 5 up and 5 down because our b value is 5. 1, 2, 3, 4, 5. There's a covertice. 1, 2, 3, 4, 5. There's another covertice. So what we do, once we plot that, okay, so we place those, then we're going to draw a rectangle connecting these points. So what that looks like is I'm going to draw a rectangle going through these points. Then our asymptotes go through the center of the hyperbola and the corners of our dotted rectangle. So it's going to look like this. Now the actual hyperbola part, okay, goes from our vertex and it gets closer and closer to each asymptote. So that would be the drawing of this hyperbola. It's a little bit more complicated than the ellipses, and it looks a lot messier, but again, with more practice, it does not take much time at all. All right, so now our information. We give our center, our vertices. Well, for our vertices, we added, because it was horizontal, we added the A value to the x coordinate of the vertex. So instead of writing them separately, what we can do is we can say 3 plus or minus 4 comma negative 2. Because that's what we did when we drew it. We took our center, which was at x equals 3, and we added 4 and we subtracted 4 to get our vertices. Then for the foci, because this is a horizontal hyperbola, we're going to be adding c to the x coordinate of our to the x coordinate of our center. And our co-vertices, we're going to be adding our b value to the y coordinate of our center. So instead of writing them out separately, we can write them this way. It maybe saves us a little bit of time. So for letter B, we're going to have to complete the square in order to tell which direction this hyperbola is going to go. So like we did before, we're going to rearrange everything, but because x squared is negative, I'm going to put y squared and the y terms first, because I know that in the end, the y needs to be up front. So from the first two, this is 64y, we can factor out a 16, and we're left with y squared plus 4. Now with the x, we have to factor out a negative 1, because that will make sure that negative sign stays in between them and not just paired with that x squared. Like everything about the x needs to share that negative sign, so that's why we're factoring out a negative 1. So now we're going to complete the square. So 4 over 2 squared equals 2 squared, which is 4. And over here, negative 2 over 2 squared equals negative 1 squared, which is 1. So now it's going to be 16 times y plus 2 squared minus 1 times x minus 1 squared equals, we have negative 127, plus I've added 4 to both sides with the y part, but I got to multiply it by 16. And then for the x's, I added 1, but I have to multiply it by the negative 1 that I factored out. So now I have 16y plus 2 squared minus x minus 1 squared equals, this right side, negative 127 plus 4 times 16 is 64, plus negative 1 is going to give us negative 64. Well, we know that for a hyperbola, this needs to equal 1. So we divide everything by 64. Now when we divide everything by 64, what happens is the y part now turns negative. So 16 over 64 is 1 over negative 4. And then we have negative 1 over negative 64, that turns into positive 64 equals 1. So now we can rearrange this, because we want the positive 1 first. So our standard form is going to be x minus 1 squared over 64 minus y plus 2 squared over 4 equals 1. So this minus sign right here, moved in between the two signs, the two terms. All right, so now we can get our information like we did in the previous problem. The center, our h comma k, is positive 1 comma negative 2. And because the x is positive, this is a horizontal one, so it's going to look like the previous problem. A squared is equal to 64, so a is equal to 8. B squared is equal to 4, so b is equal to 2. C squared is going to be a squared plus b squared, which is 68. So c squared equals a square, or c is equal to the square root of 68, which equals 2 times the square root of 17. So let's go ahead and start plotting these. So our center is at 1 comma negative 2. Now I know my a value is 8, so I'm going to have to go left and right 8 units, which is going to go off the graph in all directions. So I'm going to go up by 2s. So if I go up by 2s, my center 1 comma negative 2 will be right there. There is my center. Now from my center, I'm going to count a units or 8 units in both directions. So remember, each tick mark is 2, so 2, 4, 6, 8. There's one vertex. Then 2, 4, 6, 8. There's another vertex. Our co-vertices are going to be up and down b units. B is 2. So we're going to go up 2, down 2. Those are co-vertices. And then I'm going to connect my rectangle through the vertices and co-vertices. My asymptotes go through the center and through the corners of my box. And now the actual branches of my parabola or my hyperbola go from the vertex, getting close to the asymptotes. I want to curve this one a little bit. There. All right, so now we can identify information. We have our center, our vertices. We added our a value to the center. So it's going to be 1 plus or minus 8 comma negative 2. Our foci, we would add c to the x-coordinate of our center. So 1 plus or minus 2 root 17 comma negative 2. And then our co-vertices, we're adding b to our y-coordinates, so negative 2 plus or minus. Right, the directions didn't say to graph our foci, so we don't need to. We can just list them like that. All right, on to the next page. We got another one that we have to complete the square with, so I'm going to rearrange this to put the positive one first. So positive 25y squared plus 150y minus 4x squared minus 8x equals negative 121. And then complete the square. So factor out 25, we're left with y squared plus 6y for this part. Factoring out a negative 4, we're left with x squared plus 2x equals negative 121. Then we complete the square. 6 over 2 squared equals 3 squared, which is 9. So it's going to be 25 times y plus 9 squared. So y plus 3 squared. And then for the purple, 2 over 2 squared is 1 squared, which is 1. So minus 4 times x plus 1 squared equals, well, we have the negative 121 there still. And then we're going to add, for the pink, we added 9, but we multiplied by 25. So 9 times 25. And then in the purple, plus we added 1, but it's going to be times negative 4. So we get 25 y plus 3 squared minus 4 times x plus 1 squared equals, well, if I type that all into my calculator, I'm going to get 100. Divide both sides by 100. And that leaves us with 25 over 100, which is 1/4. So y plus 3 squared over 4 minus x plus 1 squared over 4 over 100 is 1 over 25, and that equals 1. All right, so now we have it in our standard form. Our a value, or a squared, is 4, which means a is equal to 2. B squared is equal to 25, so b is equal to 5. And again, just because the number is bigger, that doesn't make it the a value. Whichever one is positive, that tells you the a value. And because y is positive, this is a vertical hyperbola, so it's going to look like this. All right, now c squared. How much room do I have? Room. C squared is equal to a squared plus b squared, which is 29, which means c is equal to the square root of 29. So now let's go ahead and draw this. Our center is at -1, -3. And our a value is 2. So we're going to go up and down 2. And we're going up and down 2 because this is a vertical hyperbola. Then from the center, we're going to go left or right b units, which was 5. So 1, 2, 3, 4, 5. That's a covertex. 1, 2, 3, 4, 5. This is another covertex. Then I connect them with a rectangle. And then from our then we draw our asymptotes, which go through from the center through the corners of our rectangle. And then after we do that, we take our vertices and draw our, I call them branches or parabolas. So it would look like that. This is an example, another example of how the bigger value isn't necessarily our a term. This one has a vertical transverse axis because the y is positive. So now let's list everything that we need to. Our center, h comma k is equal to -1 comma -3. That was our center. Then our vertices, we added and subtracted our a value from the y coordinate this time. So it's going to be negative 1, comma, negative 3 plus or minus a, which is 2. And then our foci will be negative 1, comma, negative 3 plus or minus our c value, which is the square root of 29. And then our co-vertices, we moved plus or minus 5 units on the x direction from the center for our co-vertices. Again, this is going to take a little bit of time to get used to it, but just like with hyperbolas, your vertices, center, and foci all align on the transverse axis. All right, this last one here, I want you to pause the video and to try it on your own. You're going to have to complete the square first, and then list all the information, your ABCs, draw the graph, and then enter or write down the center, vertices, and all that other stuff. All right, so looking at this, remember at this point here, when we factored out this 16, it's a negative 16, so that's why it changed to y squared plus 2y. So then I complete the square, and you can see that I get 144 on the right side, and this is a horizontal hyperbola because the x squared term is positive. So then I listed my a, b, and c's, and this time our c value was a whole number, so it was nice to have that for a change. So then again, we plot our center at 1 comma negative 1. Then since it's a horizontal hyperbola, I went left 4 and right 4, the a value for our vertices, and I went up 3 and down 3 for our co-vertices, which was our b value. So then we could write our center, vertices, foci, and then the co-vertices. So we're trying to make this a little more streamlined. And again, just make sure you take your time and follow the steps carefully, and you'll be getting this in no time. So thanks for watching. Make sure to like the video and subscribe.